Hello everybody. Once again I am here with you for the another topic or the another point of related with the logic gates. In the previous part we have seen Boolean algebra laws. One of the additional law which is to be famous with the Demorgan's theorem, and that is very much important for the algebraic solutions or the simplifications are to be there. This is also one of the law you can say, but basically this one having the much more importance due to the De Morgan's work, or the De Morgan's theorem is famous because of it is somehow giving you conversion from the AND operation to OR and OR to and that's why it is having the much more importance, as far as the others are also having the importance according to the need of the simplification is to be there. So here is the De Morgan's first law. There are two laws of the De Morgan's. The first one is to be here, and if you look at this statement is to be very much clear, and that statement is to be in simple way. Here it is nothing but to be shown with this particular relationship is also to be there. It is some simply giving you some whatever be the sum of the complement is equal to the product of their complement is to be there. In the simple way, if I want to say, it is nothing but to be the complement of the sum is equal to product of their complement. If you look at here in this case where it is shown here with the basically, as far as the left hand side is going to be concerned, it is complement of sum. So the word is used first complement, but it is what complement? Sum's complement is to be there, and that's why the word is complement of sum. And what is sum here? A or B, that is sum, and their complement is to be shown here with the bar, that is A or B complement is to be there, and that's why the word is used complement of sum. That is what the case is equal to what you are looking here for the right hand side, that is A complement and B complement, and that is simply showing that product of the complement. Here is product is going on of their complements, that is A complement and B complement is to be there. So this is what the statement is to be, simply complement of the sum is equal to product of their complement. So if we want to prove it in a simple way, as we know that there are two variables A and B, as the two inputs are to be there, the number of probabilities of the inputs are 4, that is 0 0 0 1. Here it is to be there 0 1 1 0 and 1 1 is to be there. So these are the four inputs possibly for the two variables are to be there. So in this case, if I want to see exactly for the left hand side, either it is to be correct what exactly it gives output, and either that left hand side result is matching with the right hand side relationship, that we will check with this truth table. So these are the four probabilities, and as far as the left hand side is to be there, it is A or B complement is to be there. And in this case, if suppose left hand side, if you look at this case where it is to be A or B complement, that is the complement of sum. So first I need A or B addition is to be there, or operation is to be there. Now in this case A or B, it is some sort of OR operation is to be there, and as we know that for the two variables, OR operation is to be, or the simply having the what you called as a logic for the OR gate is to be, when any of the input is high, output is going to be high. So in that case, as far as this A or B is to be there, the output A or B will be definitely here 0 or 0, that is 0, 0 or 1, that is 1, 1 or 0, that is 1, and 1 or 1, that is 1. This is what the output for the A or B. But what is the left hand side? The left hand side is A or B complement. म्हणजे काय, लेफ्ट हँड साईडला त्याचा कॉम्प्लिमेंट आहे. ए और बी आपण बघितलं आलेल्या व्हॅल्यूज, पण त्याचा कॉम्प्लिमेंट आपल्याला बघायचं झालं तर व्हॉट इट विल गिव्ह मी, तर मग मला जे आउटपुट ए और बीचं आलं आहे त्याचं कॉम्प्लिमेंट करा. 0चं होईल 1, 1चं होईल 0, अगेन ह्या 1चं होईल 0, अगेन ह्या 1चं होईल 0. So if you look at this case, here it is shown here with this chart A or B complement, that is 1 0 0 0 is to be there. So this is some sort of, if you look at this, is simply giving you the nor or gates output is to be there. If or is gate is to be there and you are putting one not gate in front of it, it will works as a nor gate. So whatever be the truth table of the nor gate, it is simply a or b complement is to be there. So this is what the result for the left hand side is to be there. Now we are interested to see what is exactly the right hand side is to be there. So for getting the right hand side, first we need a complement and b complement, because the product is to be there for the right hand side. And that's why first I have to go for this a complement. This if a side is to be a is to be there, 0 0 1 1 is to be there. So complement of 0, there is 1, 0 again 1. For this one it is 0, for this one it is 0. So this will be the values for the a complement. Similarly, I need to find out the b complement. Again here b having the value 0, I will take it b complement as a 1. For this one it is 0, for this 0 it is 1, and for this one it is 0. So here are the values for the b complements are also to be there. So now I have the values for the a complement and the b complement. मला दोन्हीसाठी आता व्हॅल्यू मिळालेल्या आहेत, ए कॉम्प्लिमेंटसाठी आणि बी कॉम्प्लिमेंटसाठी. आता सिम्पली मला ह्याचं प्रोडक्ट करायचं आहे. that is what the AND operation is to be there in between this. So 1 into 1, that is definitely 1 is to be there here. Again 1 into 0, that is 0, 0 into 1, that is 0, 0 into 0, that is 0. So look at this a complement and b complement values are to be there. If you look at these values, which are definitely matching with the left hand side, which is to be 1 0 0 0 1. So what is there for the left hand side? It is a or b complement, and that's why the whatever be the theorem suggested by the Demorgans, that is correct. Whatever the left hand side values are going to be there, which are matching to the right hand side, and that's why we can state that a or b complement is equal to a complement and b complement, or in a simple way, complement of the sum is equal to product of their complement is to be there. So this is what the first theorem or the first law we can say as far as Demorgan's theorem is to be there. Now for to implement this first theorem, no doubt whatever be the basic gates or the whatever the gates we learn, that will implemented here. And for this implementation, it is very simple. For a and b, two inputs are to be there. Here is the one OR gate is to be used, and in front of it one NOT gate that will give us the result a or b complement. That is simply nothing but I already told you, it works looks like as a NOR gate. And for the this will be the for the left hand side. So what will be the for the right hand side? For the right hand side, we have to simply look at this AND operation we have to use. And what is the right hand side? That simply product of their complements are to be there. So I need the complements of the variables. So to get the complements, I need to use NOT gate. So a will be connected with the one NOT gate, b is connected with the one NOT gate. That will reverse the whatever the input is to be there, because NOT gate is complementary or inverted output giving gate is to be there. And these outputs of this NOT gate will be given to the one AND gate, and that will give us output a complement and b complement is to be there. So in symbolical way it will looks like this, and this is what the case where logically or the uh, logic circuit, if we want to develop, we need such type of the circuitry for to prove or to get exactly the same result as far as De Morgan's first theorem is to be there. So that this circuitry will give us the same output what the De Morgan's first theorem is to be there. So this is all about the what exactly our De Morgan's first theorem is to be there. This is what the in a lastly in a brief way, what is the left hand side, that is given here with the NOR gate, and that is a or b complement, which will be equal to a naught and b naught with connected with the and that will give us a complement and b complement is to be there. So this is all about the what De Morgan's first theorem is to be there. In the same way, whatever be the De Morgan's first theorem is to be there, the reverse to this first theorem, there is the another second theorem of the De Morgan's is to be there. In the first theorem, what we learned, that complement of the sum of their complement of their sum is equal to product of their complement, and here that will reverse, and that will give us complement of the product is equal to sum of their complement. It's just the reverse, only the word is first used, a complement. And in the first theorem, what was that? Complement of sum, and that will be equal to product of their complement, and here it will reverse. First it will come to be as an complement of product, and that's why if you look at this left hand side, this left hand side is nothing but to be given with a and b complement. That means complement कोणाचा? A and B ह्या productचा, and that's why complement of the product is equal to काय right hand side ला? A complement or B complement, sum of their complement is to be there. So this is what the statement for the Demorgan second theorem, complement of the product equal to sum of their complement is to be there. So let's see, either it is correct, or either we can prove with the truth table. Similar way we will go for the truth table, and as we know that there are two variables, and according to that there are number of probabilities of the inputs are 4, 0, 0, 0, 1, 1, 0, and 1, 1 is to be there. So as far as the left hand side is going to be concerned, we have the relation A and B complement. So first I need A and B, that is AND gate simply, and one complement that will be giving us NAND gate. So let's look at what exactly it is giving us. And here A and B, that is simply AND operation is we are aware about that. When all the inputs are high, then and then only it will give us high output is to be there. That is what the logic of the AND gate is to be there. So A and B, where it is to be there. So let's you can see this clearly. Truth table is to be there. So I will little bit shift myself. So look at this case here. A B is to be there. 0, 0, 0, 1, 1, 0, 1, 1 is to be there. And if I need a product of it, and that is 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, that will be the 1. And I need complement of this, and that will give us 1, 1, 1, 0 is to be there. So that will be A and B complement. And if you look at this case, A and B complement is to be shown here with this truth table. Here in this way, 1, 1, 1, 0 is to be there. So it is similarly as good as your NAND gates truth table is to be there. So this is what the left hand side, and what is there for the right hand side. So again I will shift myself, and that will be easy to see this truth table. So right hand side is A complement or B complement is to be there, because the statement is to be product complement of the product is equal to sum of their complement. And to get the sum of the complements, first I need a complement of these variables. A and B's complements are to be there. A चे कॉम्प्लिमेंट जेव्हा बघायचं असेल तर 0 चा होईल 1, 0 चा होईल इथं 1, 1 चा होईल इथं 0, अगेन हियर 1 चा 0. So I have the values for the A complement. In the same way I have the values for the B complement, that is 0 चा 1, 1 चा 0, 0 चा 1, again 1 चा 0 is to be there. So this is what the values for the A complement and the B complement is to be there. But what is the right hand side? It is A complement or B complement is to be there. So I have to add these two. So 1 plus 1, that is 1, 1 plus 0, that is 1, 0 plus 1, that is 1, 0 plus 0, that is 0. So this is what the output or basically A complement or B complement values are to be there. If you look at these values which are exactly matching with this, that is A and B complement is to be there. 1, 1, here it is to be there. 1, 1 again here, 1, 1, and 0, 0 is to be there. That means I can write A and B complement is equal to A complement or B complement. In the simple way, it is nothing but a statement that complement of the product is equal to sum of their complement. This is the Demorgan's second theorem is to be there. And to implement this in the logic circuit, again we will use the gates, and it is as good as I already told you, it is looks like to be as an NAND gate, and that's why one AND gate in front of it, one NOT gate if you are using, it will similarly to give you output as an A and B complement is to be there. So this is what the symbol for the NAND gate. Again, to get the another side, that is right hand side, again we have to use two NOT gate before connecting to the OR gate. And if you look at this diagram or the circuits, this is A is connected one NOT gate and B is again connected to the one NOT gate, and the output of this NOT gate will be given to the OR gate, and that will give us output as an A complement or B complement is to be there. Or symbolically it is simply shown here with the left hand side with the one NAND gate that will give us A or A and B complement, which is equal to A complement or B complement is to be there. So this is what the case, what we learn. What we learn, the Demorgan's two theorems. What is the first theorem? The first theorem is complement of the sum is equal to product of their complement. And what is the second theorem? Complement of product is equal to sum of their complement, vice versa is to be there. So this is all for the today for this session, that is De Morgan's theorems are to be there. The importance of the De Morgan's theorem I already told you is because maximum, because of it gives us conversion from the AND operation to OR and OR operation to AND. And thank you for the joining this session. Again, be at home and be safe. Thank you.